Dear students, now let us move on to the module 4, introduction to the image processing here. So in the introduction to the image processing, in the last class we discussed about what exactly the image processing and how you are going to represent the information of the images into and the basic distance metrics here. So here in this case today we will move on to the basic regulations and the distance metrics. So whatever the image that you are going to represent in the image coordinated system, so here this diagram it shows that how you are going to represent the images with respect to the coordinate system. Here we will have actually the x is equal to the with the scales of 0, 1, 2 and y is also 0, 1, 2. F of 0, 0 which specifies the pixel position on the f of xy which represent actually the first quadrant of the coordinate system here. So here with respect to the image with respect to the monitor, the always the origin will be represented at the top left corner, and the same thing that you are representing with respect to the MATLAB here. So the always here the origin will be specified with respect to the f of 1, 1 here. So the image topology, what do you mean by the image topology? Image topology, it's a branch of image processing that deals with the fundamental properties of the images such as neighborhood, path along the pixels, boundary and the connected component. Image topology which specifies that how actually the pixels in the images are having and the relationship with respect to its the neighborhood here. There are actually the three different types of the neighbors here. So the neighbors of a given pixels are those pixels with which the given pixel shares its edges and the corners here. There are actually the three types of the main topology, that is one is the 4 neighborhood topology, and another one is the diagonal element, and another one is the 8 neighborhood topology. There are actually the three types of the image topology. In that you are representing with respect to the n4 of p, that means 4 neighborhood of pixels, that is what that how you are going to pronounce that. The reference pixels p of x comma y at the coordinate position x comma y has 2 horizontal and 2 vertical pixels as the neighbors here, and that information is shown in the diagram which is shown in the 3.3. Let us see here, assume that we have actually the p of xy is the position of the pixel. So with respect to that we have actually the 2 pixels on its horizontal and also as well as the 2 pixels on its the vertical here. This 4 neighborhoods of the p, which is actually the denoted as n4 of p, where actually the pixel, the neighbor is represented with the coordinate system is given as x minus 1 comma y, x plus 1 comma y, and x comma y minus 1 and x y plus 1. So the next type of the topology is called diagonal elements, which is called actually the ND of the P here. In the with respect to that, the diagonal pixels has its neighbors here. So the next topology is called 8 neighborhood, which is actually the combination of the n4 of p and the diagonal p here. So that's why the 4 neighborhood, that how you are going to represent it the mathematically is that 8 n8 of p is equal to n4 of p union nd of p. It's a combination of that. That means with respect to that the pixel position, even we have actually the diagonal elements along with the vertical and the horizontal also. Next is we'll have the connectivity information. So the connectivity means the relationship between the 2 or more pixels, which is defined by actually the pixel connectivity. So let us take an examples of that. Let us take, we have the 2 pixels, that is p and the q, are said to be connected if certain conditions of the pixel brightness specified by the set v and specified adjacency are satisfied here. For example, let us take, we have one binary image, and this set will be set to the binary images is the zeros and the 1 for the grayscale images, and the v, whatever the value set that we have it in the v, might be of the any range of these grayscales here. Again, with respect to the connectivity, we'll have actually the 2 types of and the 3 types of the connectivity, that is 4 connectivity, 8 connectivity and mixed connectivity, which is called actually the M connectivity. 4 connectivity means 2 pixels p and q with the values from the v are 4 connected if q is in the set n4 of p. This implies any path from the P to Q on which every other pixel is 4 connected to the next pixel. Next is 8 connectivity. 2 pixels P and Q with the values from the V are 8 connected if Q is in the set 8 N8 of P. Then mixed connectivity. In the case of the mixed 8 connectivity, we have actually the drawback here. To overcome the drawback, we have the M connectivity. 2 pixels P and Q with the values from the V are M connected if Q is in the set N4 of P or Q is in the set ND of P and the set N4 of P intersection N4 of Q is empty. Let us take this is an example of that. You can see the first diagram, it shows the 8 connectivity. So here we have actually the V is equal to 1. 1 means that this pixel has to be get connected to the 1 itself, either with respect to its diagonal shape or with respect to its the 4 neighbor connectivity here. So in the case of actually the 8 connectivity, you can see with respect to this, if you apply the 8 diagonal, this is also get connected, and if you apply actually the 4 connectivity, this is also connectivity, then this actually the leads to an ambiguity here, for which particular the pixel it has and the proper connectivity. So to overcome that, we'll go for the M connectivity. In the M connectivity, what it will do actually, it overcome the drawback of the 8 connectivity represented as line here. So in the case of the M connectivity, it's actually the mixed here. Here we can connect the pixels either towards actually the 4 connectivity or with respect to the diagonal here. Here in this case 1 to 1 we have the diagonal connection, and 1 to 1 this is actually the 4 connectivity, and here instead of connecting this 1 to 1 the diagonally, we are connecting towards what exactly with respect to the 4 here. That is what. Next, connectivity or adjacency. 2 pixels that are neighbors and have the same grayscale are adjacent. So that is whatever I explained, that the same thing here. In this example, you can see that in the case of the 8 adjacency grayscale images, we have the value set is 1 to 10 here. Suppose let us take, we have the pixel is the 2. 2 is if you apply the 8 the diagonal connectivity, the 2 can 8 connected and 10 to get connected, 3 to get connected here. It won't be connected to the 100 here because the 100 is not in the set of the value. Next, M adjacency, the same thing, the whatever here written. Then the relationship. There are actually the 3 types of the relations: reflexive, symmetric. Then distance measures. How you are going to measure the distance? This is what actually the sample images. If I want to find out the distance from the P to Q or from the P to Z here, either you can connect the distance, find out the connectivity from either by using actually the 4 connectivity or with respect to the 8 distance here. Then distance measures can be given with respect to actually the Euclidean distance, and which is represented by using dE is equal to square root of x minus s square plus y minus t square. What is the advantages? It's a simplicity, and disadvantage is the computational cost. So to overcome that, we go for the D4, either you can call it as in the city block distance, and which can be calculated by using the formula, and D8 distance is also called as the chessboard distance, and it is calculated by using D8 of P, Q is this one. Let us solve one problem. Let us we have the value set 0, 1. We need to compute the Euclidean distance to 4 distance to 8 distance and the M connectivity distance between the 2 pixels here. So if you find out the Euclidean, we will be getting square root of 10. If you find out the D4, we will be getting the 4. D8 will be getting actually the 3 here. So that so there will be actually the different roots from the distance to this one. The 3 is actually the minimum, so we have to concentrate on the minimum here. So this is what exactly some of the important image characteristics that we need to follow while solving the problem here. Thank you.